Module 6. Foundations of Business Intelligence. Business intelligence refers to the process of collecting, analyzing, and presenting data to support decision-making in business. BI enables businesses to gain insights into their operations and make more informed decisions. This module will discuss BI and its components, including the data hierarchy, databases, files, records, and attributes. It will also cover relational database management systems and their capabilities. The data hierarchy. The data hierarchy refers to the organization of data into different levels, from the smallest unit of data to the largest. The levels of the data hierarchy are as follows. A bit is the smallest unit of data, represented by a 0 or 1. A byte is 8 bits grouped together. A field, a collection of related bytes. A record is a collection of related fields. A file is a collection of related records, and finally, a database is a collection of related files. Databases, files, records, and attributes. Databases are collections of data that are organized in a specific way to enable efficient storage, retrieval, and manipulation of data. Databases are typically organized into files, which contain records, and records contain attributes. It is designed to present data as it would be perceived by end users who are accessing and using the database. Files are collections of related records, such as a customer file or an inventory file. Records are collections of related attributes, such as a customer record containing attributes such as name, address, and phone number. The traditional file environment is often plagued by problems such as data inconsistency, lack of flexibility in creating reports on an as-needed basis, poor security, and complexities in data sharing. On the other hand, the traditional file environment does allow for the development of specialized applications for functional areas. Relational database management systems. Relational database management systems are a type of database management system that stores and retrieves data based on relationships between data entities. These use a structured query language, SQL, to manage data. RDBMSs offer several capabilities that make them useful for business intelligence. These include data integrity. RDBMSs enforce rules to ensure the integrity of data, such as the uniqueness of primary keys and the use of foreign keys to ensure referential integrity. Querying. RDBMSs enable users to query data using SQL, allowing users to retrieve data based on specific criteria. Security. RDBMSs offer robust security features, such as user authentication and access controls, to ensure the confidentiality, integrity, and availability of data. Scalability. RDBMSs can handle large volumes of data, making them suitable for business intelligence applications. And finally, flexibility. RDBMSs can be customized to meet the specific needs of different applications, enabling users to create custom queries and reports. Data mining. Data mining is the process of extracting useful information from large datasets. Data mining techniques include statistical analysis, machine learning, and data visualization. Data mining can be used to identify patterns, relationships, and trends in data, enabling businesses to make informed decisions. Text mining. Text mining is a technique used to extract useful information from unstructured text data, such as emails, social media posts, and documents. Text mining techniques include natural language processing, sentiment analysis, and topic modeling. Text mining can be used to identify patterns and trends in text data, enabling businesses to make informed decisions. Web mining. Web mining is the process of extracting useful information from the World Wide Web. Web mining techniques include web content mining, web structure mining, and web usage mining. Web mining can be used to identify patterns and trends in web data, such as web pages, hyperlinks, and user behavior, enabling businesses to make informed decisions. Linking internal databases to the web. Linking internal databases to the web involves making the data stored in internal databases available on the web. This can be done by creating web applications that enable users to interact with the data stored in internal databases. The process of linking internal databases to the web involves several steps. First, the data must be prepared for web deployment, which involves cleaning and formatting the data to ensure it is suitable for use on the web. Next, a web application must be created that enables users to interact with the data. Finally, the web application must be deployed on a web server to make it available on the web. Ensuring data quality. Ensuring data quality is critical to the success of data mining, text mining, web mining, and linking internal databases to the web. Poor data quality can lead to inaccurate results and unreliable decisions. The process of ensuring data quality involves several steps. First, the data must be validated to ensure it is accurate and complete. This can be done by checking for missing values, outliers, and inconsistencies in the data. Next, the data must be cleaned to remove any errors or inconsistencies. Finally, the data must be standardized to ensure it is consistent and can be used effectively in analysis.